Question 19. Which elements are shown in the increasing order of the stated property? So, first of all, atomic radius. So, phosphorus to sulfur to chlorine. As you go across a period from left to right, the atoms get smaller. That's because they get increasing numbers of protons and increasing nuclear charge. So, more attraction for the electrons that they have. They've not got any extra electron shells, so no extra shielding. So A is incorrect, they're getting smaller. The first ionization energy as you go across a period, for the same reason, because you've got increase in nuclear attraction from an increasing number of protons as you go left to right across a period, then the it's harder, more energy is required to remove 1 mole of electrons from 1 mole of gaseous atoms, and therefore the first ionization energy increases. Electronegativity, that means almost the power of them to withdraw electrons towards themselves. So how much they withdraw electrons towards themselves. Well, they're going to withdraw electrons towards themselves if they want those electrons, and sulfur is in group 6, needs 2 electrons only to fill its outer shell. Phosphorus in group 5 needs 3 electrons to fill up its outer shell, and silicon is in group 4 and needs 4 electrons to fill up its outer shell. So sulfur is closest to filling up its outer shell by gaining electrons. That will have the highest electronegativity, followed by phosphorus, followed by silicon. So they're actually getting lower. Melting point, argon, chlorine, sulfur. Well, these two are gases. Argon is a gas in light bulbs, chlorine is a gas, a green gas, and sulfur is a molecular, covalently bonded solid. So it's possible that it's D. All the others are eliminated. Argon, single atoms. Chlorine, diatomic atoms, 2 Cl's bonded together with a covalent bond, and then intermolecular hydrogen bonds. Chlorine is a larger atom than argon, so we'll have more electrons, stronger van der Waals forces, and therefore we'll have a higher melting point, boiling point, and sulfur will have a higher one still because it's got covalent bonds in a solid structure. So your answer is D. Which statement is not correct about the addition of chlorine to water? Chlorine can react with water to form an alkaline solution. No, it forms an acidic solution. It forms hydrogen chloride, which makes hydrochloric acid, which dissociates to make H+ ions. So A is incorrect. Let's have a look at the spoilers on the other ones then. B, chlorine can react with water to produce chloride ions and oxygen. Yes, in sunlight the chlorine reacts with water to make hydrogen chloride, so we can see it here. So it's made chlorate 1 ions. Those are chlorate 1 in 1 plus oxidation state. So +1 for the H, -1 for the 2. So the chlorine must be in +1, and they're called chlorate ions. Hydrogen chloride, as I've just said, then that hydrogen chloride gas dissolves in the water, it dissociates to make H+ and Cl-. So that's correct. C, chlorine can be added to drinking water to kill bacteria. Indeed it can. Chlorine can react with water to produce chloride ions and chlorate 1 ions. Yes, we've seen that above. So your answer is A.